start a new concept, that is a new chapter also, that is graph theory. Now, it is an interesting part of circuit theory. And first, anything what we used to learn, anything what we learn, we should ask our teacher who is going to make you understand the subject, why it is required. As a being an electrical student, you know circuit theory is required, and why signals that we have done, that is, I think you do have some um, insights, you are able to grow your insights that as being electrical engineer, it is very important to know about the signals, and we should have certain amount of fundamental knowledge about the systems also. Now, what is the requirement of graph theory in our syllabus? Now, you can understand that graph theory is definitely something that is related to graph. Now, and it must be definitely, when a graph is there, it must be a graphical approach. Now, why it is required in the electrical system analysis? We know that generally when we derive the system, or when we understand our electrical network, the preliminary thing we generally use is the Kirchhoff's law, right? So Kirchhoff's, how many laws are there? Kirchhoff's, how many laws? Yeah,
Ma'am,
Ronak?
Duto.
Duto, yes.
Ma'am,
Duto ma'am.
Kirchhoff's Current's law and Kirchhoff's voltage.
Yes, we all know that in case of Kirchhoff's current law, it is basically nodal analysis, and it involves the what is the amount of current entering into a node and it is going out of the node. The summation of that current must be equal to zero. That is basically the law. It has a definition, but that is the general statement of that law. And what is voltage law? Now, if there are we generally get, when there is a network, we can able to divide it into certain meshes, and what we do, we take each and every mesh and get the what is the amount of voltage involved in that loop, depending upon different passive elements as well as the active element. We know that the algebraic summation of the voltage of any mesh must be equal to zero. That is basic statement of Kirchhoff's voltage law that we know. Now, what happens when we go for this type of law? Sometimes it happens several types of complicated circuits may be there. Now, sometimes it may appear that we know that inductor and capacitor, these are two elements, they can able to handle they can able to store charge, and depending upon that they can able to create certain voltage in a system. Now, these type of elements which is able to capable of bearing energy within it, electrical energy within it, uh, sometimes it happens due to complicated connection. These type of capacitance and inductance becomes redundant. Now, what I want to mean redundant means, suppose where I know that the states, that means what is state, that voltage in the capacitor and the current flowing through an inductor. These we used to, you will know in your next class, that when we are going for a control system, we will understand there is a system called state variable analysis, that is a method of control. And what is the status? The states is in capacitor, this is the voltage, and the another is the current in the inductor. Now, redundant means where the state variables associated with those capacitance or the inductance are not really free. That is, they are not really independent. Suppose the voltage associated with the due to the complicated structure of the network, the voltage associated with this capacitance is somehow dependent on a voltage source or something else of the circuit. Okay, and when you are taking that, this capacitance voltage is not free at all. Okay, now if this type of things happen in a electrical circuit, it will be very difficult for us to solve it by using Kirchhoff's voltage and current law. ঠিক আছে, আমি এই স্টেটমেন্টটা বুঝতে পারলে না আবার বলবো কেন, মানে আমি বলতে চাইছি why we will go for graph theory। আর বলবো আরেকবার, আচ্ছা, ওকে ওকে। সো হোয়াট, আমরা যখন পড়ছি why should we go for graph theory? Now what is the problem of KVL and KCL? It is very useful, and for the regular circuits there is no need to go for graph theory and all. We can able to do it with the KVL and KCL. We are very used to it, but sometimes it appears the circuit network becomes complicated, and some what type of complication? I will give you another example, but here I am going to tell you that sometimes it is stated that the state variables, who can able to get the state variables, the capacitors who is able to get the charge, who can able to conserve the electrical energy, those type of elements can be stated as the state variables. And what are the states of that type of elements? The voltage and the current, voltage in the capacitor and current flowing through the inductor. That is the state variables we used to consider for capacitor and electricals, who can be able to hold charges, or who can able to consume electrical energy in any form. Now sometimes what happens, due to the complicated network of the circuit, these state variables are not independent. Okay, the capacitor voltages are somehow due to the configuration, probably they are dependent of certain parameters of the circuit, and if that yes
হ্যালো ম্যাম, একজন হয়তো ঢুকতে চাইছে, বলছে অনেকক্ষণ ধরে ট্রাই করছে।
আচ্ছা দাঁড়াও 1 মিনিট, দেখো তো এসে গেছে বোধহয়। আস্ক হিম। Okay, so I think so that's why I was telling that for in this type of situation, some KVL or KCL, the problem solving using KVL or KCL becomes very difficult or very complicated, and that's why, and these approaches we used to go for another approach that is comparatively easier for us, and a generalized approach, that is graph theory. And another important point I would like to mention, that is sometimes what happens, we get that the most of the time we our circuit, what type of circuit we generally get in to solve its current and KVL and KCL, they are called planar circuit. That means they have single dimension. Okay, now I am drawing a circuit for you like this. Suppose I have this type of source, and this source is connected with a resistance. Suppose there is a resistance and there is another resistance, and I am getting another resistance here. Okay, now suppose there is, in this path there is a capacitor and there is another resistance over here, no problem, but this part is attached to the last node, that is the reference node. This is the grounded, this part is attached to the ground with the inductor, and it is like this. Now if you think, if this part is connected here, there is no problem. It becomes a planar circuit, and we can get, there is a simple mesh, there is a simple mesh, and there is a simple mesh. We can able to solve the problem. But now just look, if you think of that this is a simple mesh, okay, but that means this part, I am changing the color, just try to understand. Suppose if there is a mesh, the current, the voltage is like this, and it is going to get, this is a simple mesh. Okay. And now, if I am going to get this mesh, how it is coming? It is, that means this voltage is again common for this mesh also. That means this arm is common for this mesh also. That means these two meshes are they are they are interlinked anyhow. Okay. And if you want to solve it with a simple KVL equation, it may be a difficult one for you to solve. So this type of system, they are non-planar circuits. And to avoid the complication of this type of electrical circuits, the approach, we need a simpler approach that is a general or easy way, that by virtue of which we can able to get the differential of this equation or dynamic equations of this type of complicated circuits. Okay. So for that, we should know the approach of graph theory. আমি বোঝাতে পারলাম আমরা graph theory কেন পড়ব? বোঝাতে পারলাম? তাহলে আমি নতুন, ওকে ওকে ঠিক আছে, তাহলে যেখানে we will not able to solve it by KVL and KCL, we will approach the graph theory. Okay, next. So now, তো গ্রাফ থিওরি হলে আমরা কিভাবে গ্রাফ থিওরিতে অ্যাপ্রোচ করব? দ্য বেসিক থিং হাউ, সো উই নো দ্যাট ফ্রম আ সার্কিট উই উইল এবল টু গেট আ গ্রাফ। কিভাবে সেটা করব? সাপোজ আই এম হ্যাভিং আ সিম্পল সার্কিট। আমি এরকম একটা সার্কিট দেখাচ্ছি তোমাদের। সাপোজ দিস ইজ মাই সার্কিট, দিস হ্যাজ ফলোইং ব্রাঞ্চেস, okay, and there is a voltage source over here, and there is a capacitor over here, and there is another current source over here. So this is my graph. This is my circuit. Okay. So if I think of this circuit, so how many nodes will be there in this circuit? The circuit is having a node. This is a ground node, so I can consider it as node 0. I can consider it as node 1. I can consider it node 2. I can consider it as node 3. So, how many nodes? This circuit is having 4 nodes. Okay. Now, what are the branches? You can consider the branches like, suppose this is it. I am giving, this is R1. This is having resistance R2. This is a inductance of L1. This is a capacitance of C. This is a voltage of V, and this is current source having I. Now, what is graph? Graph can be obtained from this type of network or any arbitrary network. How? Now, by replacing the voltage source and the passive elements with a short circuit and current source with an open circuit. বোঝা গেল? So how we will able to get the graph from this circuit? How we will able to get the graph? The graph is, we can get any graph from any arbitrary network by replacing the passive elements with short circuit and voltage source with a short circuit and the current source with the open circuit. Understood? তাহলে এটাকেই যদি আমি গ্রাফে রিপ্রেজেন্ট করতে চাই, কি হবে? This element, the node between 1 and 2 will be short circuit because it is a passive element. Again, this voltage between 2 and 3, it will also be short circuit because it is a voltage source. Next, between 0 and 1, so this is 1, 2 and 3 node. Now between 1 and 0, it will be a short circuit path because it is having a passive element R1. Okay. Now this is also a passive element, so it will also be short circuit path. This is also a passive element, so this will also be short circuit path. Now what happens to this path? This path will be open circuited because there is a current source. So there is no required to draw these 2 points because it is open circuited as it is. It should be replaced by an open circuit as it's a current source. So this means this is my graph. Okay. So if you consider how many branches was present in this system, this is network. How many branches? Branch 1, then 2, then 3, 4, 5, 1, 2, 3, 4, 5, and 6. So 6 branches. Okay, so that means there is 6 branches present in this graph. But how many branches we get in this graph? 6 branches was present in the original circuit. But how many branches we are getting in the graph? We are getting the branches as only 1. Then it is coming 2. And this branch is 3. And this is 4. And this branch is 5. Because we have omitted the 6th branch as it is consisting a current source. Okay, so what is the rule? The number, so from here, from this simple conversation, the rule we can form that from an arbitrary network, we can make a graph. The graph consists of at most maximum branches, just similar to the number of branches present in the network. Or it may happen that the number of branches present in the graph is lesser than the network. So the maximum number of branches, in graph is equal to number of circuit branches. Okay. The number of branches in the graph never exceed the circuit branches. It may be a lesser, but it never exceed the circuit branches. এই অবধি বোঝা গেল? বোঝা গেল তো? আচ্ছা, তাহলে আমি ফ্রেমটা ক্লিয়ার করছি। I am clearing the frame, going for the next part. Okay. Next. So now what we got, so একটা তো আমরা বললাম যে we can able to obtain a graph in this way. What is the way we know? So how can we define a graph? We can define a graph as combination of nodes and branches. Okay, so what is basically we can define a graph as a combination or collection of nodes and branches. Now nodes can also be known as vertices. Nodes or vertices. Okay, nodes or vertices. And another one is branch. So branches or edges. So the graph is basically combination of or collection of nodes or vertices and branches of edges. Okay. Now, next point comes is directed graph or undirected graph. Okay. So, what is directed graph? What is undirected graph? Suppose I am drawing a graph like this. 1, 2, 3, 4. This is my graph. Suppose this is my graph. Okay. So node is 1, 2, 3, 4, or just like our previous one, 0, 1, 2, 3. So number of node is 4 and number of branches 1, 2, 3, 4, 5 and 6. So in this graph, we are having number of nodes 4 and number of branches 6. Now there is no direction of current present in the graph. If I give certain direction of current in the graph will become directed graph. If there is no direction of current in the graph, then it will be known as undirected graph. Okay. This is undirected graph. Now, how can we convert? I can assume depending on my assumption that the current is coming from this side to this side, whatever it may be, because we know the direction of current, if it is not assumed, it is not lining with my assumption, the value only becomes negative, nothing happens additionally. Okay, that's why we can able to assume it as per arbitrarily. So suppose I am assuming that this is coming in this direction and from this node it is coming in this direction, and here this is coming, and suppose this is coming in this direction, this is this, and suppose this is this. So when we are giving the direction, this type of graph becomes directed. This type of graph is known as directed graph. Directed.
হ্যালো ম্যাম,
হ্যাঁ বলো।
বলছি ম্যাম গ্রাফে তো কোনো সোর্স থাকে না, তখন তাহলে কারেন্ট কোন দিক দিয়ে আসছে কোন দিক দিয়ে না আসছে কি করে বলবো?
এখানে গ্রাফে কোনো সোর্স থাকে না, ইয়েস, আমি তো সেই কারণেই বললাম উই আর ইউজিং দ্য গ্রাফ as a generalized way to solve our equation when we are not able to do it using the general circuit laws. Okay, now this direction is important because you can able to, আমি তো বলছি তুমি তোমার মতো you can able to get the any arbitrary direction because it is a replica of your electrical network. So if there is an electrical network exist, you can able to get, if you want to get having it is a real value, if it is given that there is a electrical circuit and if you drawing the graph, you can able to give this direction according to the network sources. Okay, but if it is not given, if only the graph is given and the direction is given, there will be no harm after what we are trying to do, the able to get the currents and voltages, we can able to find that. We will discuss it afterwards, but here what we are doing, we are taking the currents and taking the assumptions arbitrarily. Understood?
Yes ma'am.
Okay, so and if there is direction in the graph, we will call it a directed graph or a digraph. Okay, if the direction is present in the graph,
ম্যাম বলছি ডাইরেকশনটা তো আমি আমার নিজের মতো করে আরবিট্রারি
হ্যাঁ দিতে পারি।
তাহলে ম্যাম আনডাইরেক্টেড গ্রাফ আর ডাইরেক্টেড গ্রাফের মধ্যে যে ডিফারেন্সটা বললেন, তো আমি যে কোনো আনডাইরেক্টেড গ্রাফকে তো নিজের মতো করে ডাইরেকশন দিতেই পারি।
হ্যাঁ, as per your requirement, what is তোমার কাছে কি চাওয়া হয়েছে, depending upon that you have to give a direction of the graph and that will be
আর বলছিলাম ম্যাম যদি আমি অরিজিনাল সার্কিটের যে ভোল্টেজ সোর্সটা থাকবে সেই ওয়াইজ যদি আমি ওর ডাইরেকশনটা
একদম no problem. If আমি তো বললাম সেটা, if it is given that there is a circuit is given and you want to get the graph from that circuit, that is become easier because you know where is the source, how it can go. But if the graph is only given and you have to suppose it is asked that find this, then depending upon the question you will take it direction as per you arbitrarily you can take this, there will be no harm. Understood? Okay, now the next thing is an important, I am trying to giving you the definition so that afterwards we will able to know how to get that because it's something you should know. Now there comes another important definition comes about the or important terminology that is called rank of graph. Okay, so what is rank of graph? We should know rank of a graph. Now, suppose the number of nodes in that particular graph that I have drawn, the number of node was 4. তাই না? Number of node was 4. So how can we get rank of a graph? If the number of node is n, the rank of the graph will be n minus 1. So n is equal to number of nodes. Okay, number of nodes of the graph. So initially the number was 0, 1, 2, 3. So in this graph we have 4 nodes. So what is the rank of this particular graph? The rank will be nothing but 3. Okay, so this is one of the important terminology. Another thing you should know, that is called degree of node. What is degree of node? So what is degree of node? The number of incoming branches, the number of incoming branches with respect to any node, with respect to any node, is called degree of node. Degree of node. Okay, so what is degree of node? The number of incoming branches. Incoming branches. আচ্ছা, আগের গ্রাফটা আমি তো মানে যাই হোক, I am giving the direction in like this. Suppose this, this, and this, and this, and this, and suppose this. Okay, so these are, how many nodes are there? 1, 2, 3, and 4. Now, if it is asked that find the degree of node of a particular graph, how you will able to get this? The degree of node bolche the number of incoming branches. So how can you get the incoming branches? Je kono ekta particular node what are the direction? What is the direction? From that you will be able to get the incoming branches. Okay, so ekhane ami jodi dekhi the degree of node 0, suppose the degree of node 0, how many incoming branches are there? 1. তাই তো বোঝাতে পারলাম? These two are outgoing branches, this is incoming branch, will be equal to 1. Now the degree of node
দুটো ইনকামিং হচ্ছে তো,
কি হয়েছে বাবা?
দুটো ইনকামিং হচ্ছে না? ওটা একটা, ওর উপরেরটাও তো ইনকামিং এ।
কোনটা? এই যে এটাতে, এটাতে 3টে, এটা ইনকামিং। হ্যাঁ ঠিক আছে,
ওটা আউটগোয়িং।
হ্যাঁ এই দুটো আউটগোয়িং। এবার 1 এ কি হচ্ছে? 1 এ দেখো these and these two are outgoing, this is also outgoing, so 1 এ the degree of node will be equal to 0. There is no incoming branch at all at node 1. Okay, next is the degree of node 2. 2 তে কি হচ্ছে? How many incoming branches? This is incoming, this is incoming, so 2, and this is outgoing, so number of branches coming is 2. Okay, now what happens in node 3? So node 3, the degree of node will be, this is incoming, this is incoming, this is also incoming, so this will be nothing but 3. All the branches, they are coming to the node 3. So now if I add them up, what is I am getting? 3 plus 2 plus 1, so I am getting 6. Okay, so what I will, if I add all the degree of node, that should be equal to the number of branches of the graph. Our number of the branches koto chilo ei graphtar? 1, 2, 3, 4, 5, 6. তাহলে এটা কি এলো? The number of branches. বোঝা গেল? না আবার বলবো?
ইয়েস ম্যাম, বুঝতে পেরেছি।
বুঝতে পেরেছো তো? আচ্ছা, এবার হচ্ছে যেটা আমি বলবো সেটা হচ্ছে কোন জায়গাটা বলি এরপরে। ওকে, ফার্স্ট আই উইল টেল ইউ ট্রি ইজ অলসো ভেরি ইম্পর্টেন্ট, বাট ট্রি এর সঙ্গে আরো অনেকগুলো কনসেপ্ট আছে। আমি আর দু একটা জিনিস বলি যেগুলো অনেক সময় ছোট ছোট ওই তোমার যে উই ইউজ টু গিভ ডিফারেন্ট এক্সামস, সেখানে না সেই পয়েন্ট অফ ভিউ থেকে কয়েকটা জিনিস খুব আসে। অনেক সময় বলা হয় যে কমপ্লিট গ্রাফ, হ্যাঁ, হোয়াট ইজ কমপ্লিট গ্রাফ, হোয়াট ইজ ইনকমপ্লিট গ্রাফ, তো সেই জায়গাটা আমি একটু বলে নিই, ট্রিটা না হয় পরদিন ধরবো। আচ্ছা, so the next thing I would like to mention, that is called complete graph. Okay, so what is that? Complete graph. Now what is a complete graph? Complete graph consists only one line segment per node pair. Okay, বলে দিচ্ছি ভালো করে। Suppose we are having 4 nodes, 0, 1, 2, 3, so 4 nodes. Now how our graph was directed? It was like this. So node pair 1 and 2 is having one branch, node pair 2 and 3 is having one branch. Now node pair 1 and 0 is having one branch, node pair 3 and 0 is having one branch, and node pair 2 and 0 is having one branch. তাহলে how many node pairs can be paired? How many nodes? আমাদের চারটে নোড আছে। নোড পেয়ার কি কি হতে পারে? 1, 2, this may be a node pair. এবার next 2 and 3 may be a node pair. 1 and 3, 1 and 3, each may be a node pair. 1 and 3, each may be a node pair. Next is 1 and 0. 1 and 0, it may be a node pair. 2 and 0. 2 and 0, it may be a node pair. And 3 and 0, it may be a node pair. তাহলে কটা হলো? 1, 2, 3, 4, 5, 6. 6 node pairs are present. 6টা নোট পেয়ার প্রেজেন্ট আছে, 6 নোট পেয়ার্স আর প্রেজেন্ট। এবার আমি তোমাদের বলছি দ্য কমপ্লিট গ্রাফ is that graph which is having only one line segment per node pair. The complete graph is something which is having one line or a branch or one line segment, one line segment, only one line segment, only one line segment per node pair. যদি কোনো একটা পয়েন্টে, সাপোজ এই দুটো পয়েন্টের মধ্যে 3 আর 0 মধ্যে কোনো কারণে যদি দুটো ব্রাঞ্চ থাকে, দেন ইট ক্যানট বি আ কমপ্লিট গ্রাফ। কমপ্লিট গ্রাফে কি হবে? যে কটা নোড পেয়ার আছে সেই কটা নোড পেয়ারের মধ্যে অনলি ওয়ান লাইন সেগমেন্ট প্রেজেন্ট থাকতে হবে। আমি বোঝাতে পারলাম? So as per that definition, this graph is a complete graph because each and every node pair is having only one branch or one line segment. বোঝা গেল? না বোঝা গেল?
হ্যাঁ ম্যাম।
আচ্ছা, এবার আমি যদি if I draw the graph in this fashion, suppose this, I am having a graph like this, this. So this is 1, 2, না আমি এটাকে নামটা চেঞ্জ করছি, A, B, C, D. I am having a graph like this. I am having a graph like this. Okay, suppose I am having a graph like this. এবার আমাকে বলো how many node pairs are there এখানে? কটা node pair তৈরি হবে?
6টা।
6টা, হ্যাঁ। তাহলে AB, BC, AC, AD, BD and CD. But can you tell me whether this graph is a complete graph? Is it a complete graph or an incomplete graph?
কমপ্লিটই তো মনে হচ্ছে।
কেন কমপ্লিট? এই দেখো, এ আর বি, এ বি নোট পেয়ারের মধ্যে আমার একটা আছে, ঠিক আছে, এখানে আছে 1 আছে। বিসি নোট পেয়ারের মধ্যে একটা ব্রাঞ্চ আছে, ঠিক দিলাম। এসি নোট পেয়ারের মধ্যে কোনো ব্রাঞ্চ আছে?
এইটা তো আছে।
তার মানে এটা হতে পারতো, দ্যাট ইজ নট কমপ্লিট। বাকিগুলো আবার আছে, এডির মধ্যে আছে একটা, বিডির মধ্যেও একটাই আছে, ডিসির মধ্যে আবার সিডির মধ্যে একটাই আছে। কিন্তু অ্যাজ এইখানে কিছু নেই, এটা হতে পারতো, সো ইট ইজ নট আ কমপ্লিট গ্রাফ, ইট ইজ আ ইনকমপ্লিট গ্রাফ। আন্ডারস্টুড? একই রকম ভাবে যদি এরকম হতো আমার সিস্টেমটা, সাপোজ এ বি সি ডি, now there are 2 branches in CD, এটাও আছে, এটাও আছে, এটাও ইনকাম, হ্যাঁ। এখানে কমপ্লিট হওয়ার পর অ্যাডিশনাল, বিকজ এইটা তো আছে, তার সঙ্গে ডিসির মধ্যে 2 পার্টস আর দেয়ার। কিন্তু আমরা বলছি বাই ডেফিনেশন কমপ্লিট গ্রাফ উইল বি, যেখানে কিনা, হ্যাঁ, যেটা হতে পারে মিনিমালটাই থাকবে, তার বেশিও থাকবে না, তার কমও থাকবে না, তাই তো? সো অ্যাজ পার ডেফিনেশন দিস ইজ আ ইনকমপ্লিট গ্রাফ, because this is not present, and here as it is present, that is why it is also becoming incomplete graph as per definition. বোঝাতে পারলাম?
Yes, ma'am.
Yes. তাহলে এখানে একটা অনেক সময় আমি ওই জায়গাগুলো একটু বলে বলে যাই। অনেক সময় একটা ফর্মুলা আছে, বুঝলে তো? ফর্মুলাটা হচ্ছে যে হাউ মেনি ম্যাক্সিমাম নাম্বার অফ ব্রাঞ্চেস ক্যান বি ফর্মড উইথ আ নাম্বার অফ নোডস। হ্যাঁ, সেখানে দ্য ফর্মুলা বিকামস বি ইকুয়াল টু NC2, কারণ আমরা জানি কম্বিনেশন করে হবে, দুটো নোট পেয়ার দিয়ে তুমি কটা ব্রাঞ্চ ফর্ম করতে পারো। তার মানে যদি এটাকে আমি সিম্পল ফ্যাক্টরাইজ করি, তাহলে এটা দাঁড়াচ্ছে n ফ্যাক্টোরিয়াল, আর এটা দাঁড়াচ্ছে আমার n-2 ফ্যাক্টোরিয়াল and 2 ফ্যাক্টোরিয়াল। এবার এখান থেকে তো আমরা জানি we can able to get n into n-1, this factorial tool will be omitted and it will be 2. So this is the formula for to get the minimal number of branches with a node pair. ঠিক আছে? তার মানে একটা কমপ্লিট গ্রাফ তৈরি হতে গেলে তোমার কটা ব্রাঞ্চ লাগবে সেটা তুমি কিন্তু এই ফর্মুলাটা দিয়ে বের করে নিতে পারো। আন্ডারস্টুড? যেমন আমি যদি এখানেই, আমি আজকে হয়ে গেছে টাইম, আমি শেষ করছি, আমি জাস্ট একটা এক্সাম্পল দিয়ে বলছি তোমাদের। সাপোজ আমাদের এখানে যেমন আমাদের 4টে বলা আছে, হাউ মেনি নোডস প্রেজেন্ট, না নাম্বার অফ নোডস প্রেজেন্ট ইজ 4। তাহলে কটা টু মেক আ কমপ্লিট গ্রাফ আমার কতগুলো ইয়ে লাগবে, কতগুলো ব্রাঞ্চ লাগবে? ইফ আই গো ফর দ্যাট ইট মাস্ট বি 4C2, আর এটা যদি ডিরেক্টলি আমি ফর্মুলায় ফেলে দিই, ইট উইল বি 4 into 3/2, so it will be becoming number of branches will be nothing but 6. আমার 6টাই ব্রাঞ্চ আছে। বোঝা গেল তো? হ্যাঁ, এরকম থেকে তোমাকে এরকমও দিতে পারে যে সাপোজ ইউ হ্যাভ ব্রাঞ্চেস, নাম্বার অফ ব্রাঞ্চেস গিভেন, সাপোজ তোমার 66 বলে দিল। এবার তোমাকে বললো ফাইন্ড নাম্বার অফ নোডস। তোমার যদি ব্রাঞ্চেস 66 হয়, তাহলে কটা নোড তোমার সিস্টেমে থাকবে সেটাও তুমি এই ফর্মুলা দিয়েই বের করতে পারবে, তাই না? হ্যাঁ, so you can able to get the node if branches is given, if you have to remember this formula n into n-2 equal to branch, okay, where n is নোডস অ্যান্ড বি ইজ ব্রাঞ্চ। ঠিক আছে, তো আজকে এই অবধি থাক, কারণ 3:10 এরপর তো তোমাদের আবার ল্যাব আছে। ওকে, 1 minute, I have to take the attendance.